So welcome to the BESS working group meeting. If you could make sure that you register with the... Oh, is it not on?
We can hear you very well here.
No, that's dead.
It's the end, huh? Central controller.
Yeah. Sorry, I did. They're all dead. Can you just, when the mics come up, can you just kick it off? Because I need to at least get onto the Meet Echo before we do anything.
So we'll start with the mic.
When the mics come back, Stephanie's just gone to find somebody. So we're just going to wait for a couple of minutes until the mics are up. Yeah, they're not working. So looking at the board. Sorry? Oh. Yeah. Can you send a message to the queue? Just send a message to the list. Not to this, to the they're all like this. I don't know if they've been switched off yet.
Dubaya, would you please confirm that you can actually hear us?
We can hear you remote.
Okay, thank you. It's just the room speaker, so we'll see what we can do.
Well, where's it picking it up from? Oh, it's just the PA that's not on. Yeah, okay. We have nothing but good things to say. And we have no secrets, yes. Testing. Yes.
One,
good.
two.
Okay.
1, 2.
Hello, can you confirm you are me from remote?
Yes, we can hear the remote.
Okay, perfect. Thank you.
Can you start? Because I'm not on.
Hello, everyone. So this is BESS working group. We are getting started now after some technical issues. Co-chair Stefan is remote. Matthew and I are here. Our secretary, Mankman, cannot join us today. Okay. So note well. I hope everyone is already aware of this very well. Everything you say, anything you say, communicate here in IETF is subject to this notice. Meeting tips: if you are here in person, make sure sign into the session, use Meet Echo, join the mic queue. You can scan the QR code over there on the screen. Remote participants, please mute yourself and unmute when you are allowed to speak. Can we get a volunteer for the notes taker? Anyone?
Please, could we have a note taker? It'd be really helpful. Otherwise, we may have to rely on the automatic transcription, and anything you say may be translated into a really strange thing. So if you don't want to be embarrassed. Okay, thank you. Thank you. I really appreciate that.
Okay. We had a full agenda, but now we had one presentation dropped, so we may have some extra time, but we'll try to go according to the schedule. Before we start the agenda list, we have a new routing area director, Gunter. He's taking over as our responsible AD. Welcome, Gunter, and good luck. And thanks for our outgoing AD, Andrew Austin, for his stewardship over the last few years. So working group status updates, we have RFC 9489 published since last IETF, label switch path ping mechanism for EVPN, and provider backbone bridging EVPN. We have 6 documents in the RFC editor queue. Here we have these 5, but actually there is another one that just got moved into our RFC editor's queue. It's the IRB multicast draft. We have quite a few under AD or IESC review. This includes one that just got moved to the RFC editor's queue here. I don't think we need to go through this one by one, but I'll leave it on screen for a few seconds so that if you see anything that's any discrepancy, you can speak up.
One thing I'd just like to say is that on the SD-WAN usage draft, there's a couple of IESG discusses on that from various ADs. I know that the editor, Linda, has responded to, I think, to both of those now. We're still waiting for either a yes or a no from those ADs to try and clear those last discusses. It won't move forward, obviously, until those have cleared. Gunter, I don't know if you have anything else you want to say about the progress of that draft in the IESG.
At this point in time, not much more to say about that.
So. I have a question.
Go ahead.
I'm wondering with respect to the first 3 drafts, when it says with AD, can you please clarify what needs to be done by the AD? And the reason I'm asking this question is because, especially with respect to the first draft, AD needed to respond to an email, and Andrew did that like last time in November. So I'm wondering, like, if that got clear, why is it not moving?
Well, you know, I'm literally AD for about like 5 minutes, and you put. So thank you for that a lot.
Congratulations, Gunther.
So I'm gonna postpone my answer on that, and I will look into it, and I will come back to you.
Sounds
maybe
good.
Andrew has something to say about this, but otherwise I will come back to you. Okay.
Thank you.
Okay, we'll move on to the next slide. documents under Sheriff's review. We have quite a few waiting for the Sheriff to write up. There's one waiting for implementations. So if you know about any implementation about the last one, EVP in Geneva, please let us know so that we can move it forward. We have two documents failed working group last call. The first one, L2 Gateway Protocol, too little support to demonstrate a working group interest. Please speak up on the list if you want to see this progress. The second one, we are basically waiting for the review for the latest version from IDR.
Say something about that. So on the IPVPN interworking draft, so there was one review done by the IDR chairs, and there was some discussion with the authors about a year ago, I think, and they made some updates to the draft. And I think, Jeff, you were planning on having another look at the draft and provide some more feedback.
Yeah, so I have partial edits in the queue right now. I just need to finish them up. So this is totally on me.
Okay, thank you. Yeah, so I think what we should probably do with that draft is once we've had sort of consensus with the IDR chairs on it, we should probably do another short working group last call and then move it forward if we don't have any issues raised during the last call. Himanshu, can you try and remember to use the on-site tool and to get in the queue?
Himanshu from Siena. I know you said to express the interest on layer 2 gateway protocol, but we want to progress this. So I'm interested in getting it progressed. I have some few clarification questions and I'll talk to the author about that.
Okay.
So we have quite some documents ready, potentially ready for working group last call. AC, we're abandoning drafts. We have seen quite a few questions, comments on the list. I think, in fact, there is one from me as well. I talked to Jorge about it and had we agreed that there's some change needs to be done. Then the next one, broadcast flow DF election is expired. It needs to be updated to address some comments on the list. The extended optimized ingress replication, we have finished the routing directories review and JNR review. The comments have been addressed. So I think we should be able to move to the next step. The 7432 BIS drafts, we finished the routing directory, the review, and then the comments have already been addressed. We also started requested JNR review. I do believe there is at least one change need to be made to the DF election procedure. The existing wording there is quite confusing. I talked to one of the co-authors before. I think that needs to be addressed. The multicast controller drafts, both the routing directory review and JNR review have been addressed. We just need one more confirmation from the reviewer that the comments have been really been addressed. But on the author side, we have done addressed the issues, I believe.
Greg, you're in the queue.
Greg Mirsky, Ericsson. So my question, is this exhaustive list of work documents that being considered for a working group last call?
No, it's not totally exhaustive, but it's a top, like if we've missed something, then
No,
drop
it's
us an
not
email again.
I just think that it might be good to keep the progress of EVP and OEM documents, publications, and working through after their publication of extensions, LSP ping specific for EVPN, with their complete work on BFD for EVPN, because I'm one of the co-authors, and I believe the document is stable and ready for comments and then progressing.
Yeah. Okay. So if you send us an email, send
Okay,
on that, and so the way that we manage this, because we have a lot of individual drafts that need to be managed for the work and IETF drafts, obviously, to be managed for these two queues. And the way that we do it is that we use the wiki. So we'll add those. We'll have a look at them and add them to the wiki.
I might check. It might be already there.
Yeah.
Thanks.
Continue on the list. The BGP multicast drafts, both the director review and GNR review have been addressed and then confirmed. So it should be able to move forward. The seamless MVP and EVP and seamless interop drafts, we have received comments for those early reviews, and drafts is being updated. Finally, the SRv6 ARCs documents, we have received a request for expedited last call, and I think it started already. I see.
I don't think it started yet, but because it was only a couple of days ago. Okay. But so I accept this. This had quite a quick working group adoption poll not very long ago, and this is now on version 1 of the draft, but it kind of clarifies some of the text in RFC 9252 based on implementation experience. So I think it's fairly important to make sure that we don't end up with some implementations done in a particular way because of a different interpretation of the RFC.
We have a long queue for the adoption call. Actually, the first one, DPass drafts, the call closed on Wednesday. We believe we have received enough support and we should accept it. IP aliasing, that's actually accepted already, and then the working group version has been published. The map Sapphire drafts, the authors need to clean up the author list first, and then we should be able to start call on that one. And the next one, secure EVP max signaling, that one we didn't get enough support, so it's failed. The next two, IPv6 infra and the MVP and EVP and SIM multicast enhancements, those two drafts need to be considered together because the use case for the IPv6 infra and the problem there has been discussed in the next draft as well. They have different solutions. We want to discuss them. In fact, there have been a lot of discussions. We just need to get a conclusion. So please review the discussion and then see which way we want to go. I will have some discussion on that one later as well. So the upstream DFE selection that has also been requested. I believe we need more discussions on the mailing list. The fast reroute one, a review request was sent to Spring Working Group. I believe there was one comment from another group of authors for another draft about whether we should use a different behavior for SRv6 or just use a flag. I think that discussion needs to happen and close. And then finally, the private MPLS label drafts. We need a cross working group review with MPLS and IDR working group.
Okay, so I think Donald.
All right. Well, Donald Eastlake with the Future Way. On the drafts potentially ready for a working group last call, I believe at the last meeting, you agreed that BESS, EVPN, BFD should be included in that list, but I didn't see it.
Yes, we need to add that to the wiki as well. Like I said, we track those on the wiki. If you see anything that you have asked for and the chairs have agreed to it and then not updated on the working group wiki, we keep a queue, so you can see what's in the queue. To send us a reminder. Yeah, sorry, thank you. Yeah, we generate the slides based on what we've done there. Okay, so I think first is Greg. It's probably better if you just share his slide. Yeah.
So thank you for inviting to present work in MPLS working group on first nibble. So you will notice that traditionally that construct was referred to as MPLS first nibble. Then further discussions, we realized that it's misnaming because this first nibble is not really a part of MPLS label stack. It's a part of what follows the label stack immediately. So that's why one of their terminology changes and to refer to it as a post-stack first nibble. So don't be surprised. It's the same thing, same 4 bits. Okay, so why do we need this? Because so the first stack, post-stack first nibble is a construct that first 4 bits that immediately follow the label stack element that has bottom of the stack flag set. Historically, what realized that for load balancing, some implementations for several reasons try to deduce their type of a payload under their label stack based on the value of first nibble. As when MPLS was defined and architected, so we agreed that it has native payload being IP, whether IPv4 or IPv6. So thus, it's assumed that if the first nibble values are either 4 or 6, then it's safe to assume that the payload is either IPv4 or IPv6, and then use that information for any generation of the entropy. Also, with the development of pseudowire technology, so assign values 0 for the data and 1 for associated channel header, VCCV, so that can be differentiated from IP payload. For the pseudowire, there are several types of pseudowire being defined. One of them being Ethernet, might be probably the broader deployed. And later on, yeah, actually in the course of standardizing their solution for Ethernet pseudowire, we as the group made a compromise. We made the control word an option. And that later realized that it was not the best solution, because there then some of MAC addresses not being preceded by pseudo-wire control word, which is in fact can be generalized as a post-stack header, could be mistaken for the MAC address. We try to mitigate that by recommending use of pseudo-wire control word, but still that's an option. So effectively what been realized that some implementations might use the only value of post-stack first nibble as an information to deduce the type of a payload, which is wrong. That's not how MPLS works, because only last label or group of labels at the bottom of the stack can assure what the type of a payload is encapsulated in a label stack. So that's why we want to first document which numbers for first nibble being in use, because it's not only 0, 1, 4, or 6, but at the same time to use this opportunity to deprecate cases where non-IP payload encapsulated without post-stack header. And for that, we give their definition of what deprecation means in the context of this document. So the deprecation is different from the next step, more severe, it's obsolete. So deprecation is referred to new implementations and deployments. So thus, new implementations that will support this specification must not use non-IP payload without post-stack header. And our intention is, after this document is published, or might be in concurrently, to start work on a document that will obsolete this non-post-stack header use. Yeah, thank you. Okay, so I already mentioned that one of the concern, well, the major concern for us was that the only way some implementations use the only value in a post-stack first nibble to do load balancing, and that leads to some undesired outcomes. So that only can be done for if the value of first nibble is either 4 or 6, because that is exclusively used for IPv4, IPv6 respectively. Okay, so how PFN can be used safely? It can be used only in combination with their bottom of the stack label or label group, because only that defines their type of a payload. But at the same time, as we know, for example, from pseudowires, so the value of post-stack first nibble will differentiate the payload from OEM, so from the management control payloads. And that's been done in, for example, reused in deterministic networking with MPLS data plane. But on the other hand, Beer decided after discussions, they decided to use the value of the first post-stack nibble in Beer encapsulation over MPLS data plane as 5, and then use an explicit protocol identifier for OEM payload. So thus, one needs to know that this is a Beer label at the bottom of the stack to understand that that the Beer follows. The 5 might not be sufficient. As part of the work, we updating RFC 4928 to do clarify and really make their normative language stronger in regard to the use of post-stack first nibble, and to introduce this terminology as a post-stack first nibble and post-stack header. And the other part of this work is to prepare format for IANA registry of post-stack first nibble. I just want to mention that we received the early review from IANA, and this format that is reflected here in the slides and in the current version of the document, it's not that how it's going to be, because IANA informed us that they cannot create registry like that. They really thoughtfully offered us 3 options that we'll discuss and consider, and then update and bring it to MPLS working group for review, and everyone is welcome to review and comment on MPLS working group list. But our idea was that to highlight it based on applications that use first nibble values of any value, rather than, because the prior version was listing the values in ascending order, and that because the same value was used by several applications, well, we thought that it might be not clear enough. We'll try to find a compromise between several desired outcomes. So what we want to message to convey today. So the control word in 7432 BIS, again, as we suggest, deprecating their use of the option of not using pseudo-wire control word for non-IP payload is deprecated. And we'll appreciate your consideration in reflecting that in 7432 BIS. Welcome your comments, questions, and please include MPLS working group in all discussion related to this post-stack first nibble and use of a pseudo-wire control word.
Okay, I think you're first in the queue. I just wanted to mention that it's probably also relevant to RFC 8214 as well. It also has similar text about, I believe, about how you do load balancing.
That's right, yeah. So Jorge Robalan, no, my question or my ask to you is, there's a clear section in 7432 BIS talking about control word and how you signal it and how you use it. So can you go through it and let us know if you're happy with it or you want to change it?
Yeah, well, okay. Okay, first, will do. Second, some time ago, I read it, and I think that my impression that based on our recommendation and our action coming out of this work would be that control word must be present all the time.
Okay. Because in the old 7432, there was an option to not use it.
Yes.
So,
Again, that's the compromise we've made, and now we're paying for it.
I think the text, sorry, just to interject that, the text in the original RFC was not really, there's an option not to use it. It was actually more of a, you mustn't use it or you shouldn't use it if you believe, for example, if you have entropy label inserted on there, but I think the comment against that was you don't know what, the head end doesn't know how the entropy label is, or if the entropy label is going to be used by an intermediate LSR for the load balancing. It's just another label in the stack.
and we recently changed the text because of your comment, so maybe it requires more discussion on the list, I guess.
So if I may, I raise question is, how do I know that it is my turn? Hello?
Go ahead, Ali.
Okay. My question is, section 18, we have gone through it with the fine comb to make sure that, you know, all the dots, all the I's are dotted and all the T's are crossed. So I highly recommend going through that section, you know, let us know if if there is anything missing, because it's cover multiple scenarios, including when the tunnel is RSVPTE. So my question to you, Greg, is for the RSVPTE tunnels, do you still mandate the use of the control word and the PFN?
Okay, thank you. Okay, a couple of things. I think that PFN will exist regardless of whether there is a control word or not, because then only the question will be, what would be the value of that PFN? Because if it's IP payload, then it will be 4 or 6. If it's a control word, it will be 0. If it's associated channel header, it will be 1. If it's something else, it might be something else. And thus it could be, again, 0 or 1, because some Macs can get that. But our concern is for transit nodes. So for transit nodes, doing something for the load balancing. And without the concern that we have, and why we proposing to deprecate use of non-IP cases of non-IP payload without post-stack header is then it becomes unpredictable and basically their load balancing by transit node might be unpredictable regardless of what this LSP is.
So that basically that's what we've emphasized in that section 18 of the packet reordering, to make sure that there is, you know, when there is chances of load balancing, we insert the control word and make sure that all the packets of a given flow are delivered in order. But when there is no possibility of load balancing, such as traffic engineering tunnel, we don't want to burden and add additional control words when it doesn't serve a purpose.
Okay, I sympathize with this effort to optimize, but first, in our current state of technology, saving 4 octets, it might be not that significant gain comparing to the complexity of the logic. So might be it would be acceptable. And again, as I said, I'll read the document again. I'll read the document very carefully, and we'll discuss it with other authors of this work, and we'll come back with our questions and suggestions. But on the first take, it seems to me that making the use of a control word mandatory across all use cases might be the simpler way.
Yeah, let's take it to the list.
Yeah, but we'll take it to the list. And again, please, in everything, in all discussions related to this document, please include MPLS working group.
Okay, thanks.
Thank you.
So next is Jorge.
Thanks. Yeah, I'm not taking notes for this. It's okay.
That's okay.
All right. Yeah, welcome. So this is first draft is about yeah, layer 3 fast convergence and aliasing backup for inter-subnet forwarding, or also known as IP aliasing. Yeah, so the document was adopted some time ago, and basically the high-level summary is that we want to bring all the benefits of aliasing and mass withdrawal and all that we had in EVPN layer 2 routes for inter-subnet forwarding. And this is done based on two types of Ethernet segments. The Ethernet segments are associated to a set of Ethernet links. That's what we use in the use cases 1 and 2 in the document. And then there's a third case, which is an Ethernet segment as a layer 3 construct. And that is what we use in the use case 3 in the document. So we received quite a bit of feedback in the meantime. So in the latest version, we tried to address all the comments and questions, and mostly clarifying some scenarios for use case 3, and also things like when you have an Ethernet segment that is shared for layer 2 and layer 3, because you are in the use cases 1 and 2. In the IP verf, you really need to use a different route distinguisher so that the AD per ES and EVA routes, they are actually different. We also fixed some typos and updated references. And well, the idea is please give us more feedback if there is or there are more things to clarify. We are happy to improve the text. Otherwise, we should be looking at moving this to working group last call. Okay, the next one is interdomain option B, solution for EVPN. This document is informational. It does not create new EVPN procedures. It basically summarizes the impact of the interdomain option B connectivity in the EVPN procedures. Includes all the EVPN different services, meaning ELAN, E-line, E3 services, also inter-subnet forwarding or layer 3, as well as PBB EVPN. The idea is that it identifies the potential issues you may go through when you have this type of scenario, and analyzes potential solutions for those issues based on the existing specifications and some local implementations that do not change the control plane. That's why it's informational at the moment. The document talks about these two option B models. So the first one on the left-hand side is basically you have multiple domains. Each one is typically mapped to a different IGP domain. And you have border routers stitching those domains. On the border routers, you do not have a VRF instantiation. And typically all those domains are part of the same AS number. So in that case, basically, as you would expect, you have ingress piece, egress piece. The egress piece will advertise the routes. The border routers will do next up self, and they will program this service label swap operation for the data plane. On the right-hand side, you have a slightly different model, but same procedures. So this is typically inter-AS model B. So each domain is really a different AS number, and the border routers can be directly connected. And here in this context, basically, we talk about verfs as a abstraction. So it can be a MAC verf or an IP verf or even a VPWS instance, right? It doesn't matter. Then the labels that you can see here, the EVPN labels can be 20-bit labels for MPLS tunnels, or it can also be 24-bit labels in case of MVO tunnels or VNIs. The option B procedures or issues were originally specified in RFC 8365, but there were just a couple of pieces here and there, so that's why we decided to put together an informational document. It's good to say that for MVO tunnels, there are no transport tunnels. So the transport tunnels that you see here in the diagrams are supposed to be for MPLS, not for MVO tunnels. So anyway, the version 00 was presented in IETF 116, and ever since we refreshed the draft, we added Wen as co-author, and we appreciate her insights. We added all her comments as well. We improved the terminology section. We also clarified that when you are in EVPN ELAN sort of scenario and you have different MTUs in different domains, it's actually good to signal MTU 0 to make sure that we don't have issues with the establishment of the tunnels. What we want for the next steps is more feedback from the working group. We believe this work is needed, and we would like to ask for working group adoption. Jeff?
Jeff Ventura, NVIDIA. Back to the Arising draft. I think it's ready for working group call. It's really readable, implementable document. Question for you is implementation report. Quick search shows actually Nokia supporting it, but what about the rest of the industry? Could you please include implementation report?
Okay. Do we do implementation reports in BESS?
Well, we do implementation polls. We have been discussing amongst the chairs about how to maybe better manage this going forward so they're preserved somewhere. Because at the moment, all we're really doing is polling the list at a working group last call time to say, do we have at least one implementation, which probably we've had some comments that maybe this isn't sufficient, and we need to be able to preserve that information somewhere as well.
Yeah, IDR practices might be in place, and usually we use Wiki in ATF for that. But even if you include it in draft and then remove before publication, it would be very, very useful.
There is also a way you can do it through the data tracker. There's a tag you can add to the further information for a document for related implementations.
Would be great, and really good work.
Yeah, we are open to whatever we decide we can do. Yeah.
Say anything about it? I know you've implemented it, but is there any interoperability testing? Anything?
Not as far as I know. So I think I replied to your email on the list. I know 2 implementations, but I don't know if there are some others. So
thank you.
Thank you.
Just a quick question. With respect to the implementation, isn't that for the implementation, basically we asked the working group during the working group last call, not the working group adoption, right?
Is that a question for the chairs or?
For the chairs.
Sorry, I'm just trying to get.
I'm sorry, I missed your question.
The question is with respect to the implementation. This is typically for the working group last call adoption, as far as I can remember. Is that true? I mean, not for the working group adoption.
Sorry, the question is around the implementation.
Yes.
Yes, that's a working group last call time. I think that's why I mentioned that when I discussed it.
Okay, so I think
it's always good.
Jorge is asking for working group call adoption.
Well, no, last call, right? Ali?
Oh, this is last. Option B, okay.
Oh, no. It's it's presented option B, but this discussion was about the IP aliasing draft.
Okay, I thought it was with respect to the option B that you're presenting right now.
Oh, no.
Okay.
Yeah. Sorry about that. Yeah.
He has one more.
I think we should probably take the rest of this. Oh, you have one more, don't you?
Yeah.
I have one more. Yeah.
Can you show that one?
We can make it short. Okay, short refresh about this one. This is about multicast forwarding for EVPN to EVPN gateways. And basically the idea was to fill a gap that we had in the current specifications for EVPN multicast on service gateways. So on one hand, for layer 2 service gateways, we had RFC 9014 specifying how to do the gateway thing for unicast traffic, layer 2 unicast, and BUM traffic as well. And on the other hand, we also had RFC 9251 defining the IGMP MLD proxy procedures within the same layer 2 domain, right? EVPN broadcast domain. But we were missing basically how to do interdomain for IP multicast, right? For layer 3 service gateways, a similar thing. We had a specification for unicast saying how you do the interdomain for layer 3. We also have the OISM recently approved draft that talks about how to do inter-subnet multicast forwarding within the same EVPN domain, and also specifies how to do the stitching to MVPN or PIM domains. But there was a missing piece, which was the layer 3 multicast between, EVPN domains, EVPN to EVPN with a service gateway. Because of that, this draft is actually addressing those two gaps. And we presented this in the past. The two diagrams that you have here is actually the two use cases. On the left-hand side, you have the layer 2 interdomain case. So you have two EVPN domains for the same broadcast domain. All the Ps are attached to the same broadcast domain. And the gateways in the middle that are stitching the two domains, and they are performing this proxy function for SMET routes and re-advertising into the adjacent domain a single EVPN SMET route doing the proxy function. In a similar way, on the right-hand side, you have the layer 3 scenario where you have basically an OISM domain at the bottom, and you have an OISM domain at the top, and you have these two gateways in between that are stitching things together. Same thing, the gateways, they need to have some procedures. They have an SBD or supplementary broadcast domain per domain they are stitching. They run a DR election, and basically the DR is acting as the first hop router for the other domain, right? So it'll create a multicast state, and it'll do a sort of a first hop router function for the SMET routes that is advertising into the adjacent domain. So anyway, this was presented in an IETF 115, so you have more details on those slides. And ever since we presented this, we have refreshed the draft, and we improved some sections, terminology, typos, references, and we also fixed a bug in the draft. It was saying that you could only aggregate SMET routes for star comma G and S comma G if the received SMET routes had the same multicast flags, which is not true. You can have different multicast flags, and you can still do the aggregation. And with that, basically, what we are requesting is not moving.
So not going forward.
All right. So more feedback from the working group, and ask for working group adoption since the draft is pretty stable. Okay. Thank you.
Thank you.
Quick question.
Yeah, go ahead, Ali.
I'm wondering, Jorge, with respect to the gap in RFC 9014, we do these gateway functionality and interworking for the unicast rod type 2 and rod type 5 and broadcast traffic, but as you mentioned, not for multicast. So have you considered to do it as part of the RFC 9014 BESS, so that we make it more comprehensive and have it in single depository?
We could do both ways, but this draft is not only addressing RFC 9014 for multicast, but it's also addressing the layer 3 part, which is the EVPN, IPVPN interworking draft and OISM. So, you know, if we did it via RFC 9014 BESS, we would be addressing only half of the problem. So,
The OISM, doesn't it have already a interworking section? Are you saying that is not, that doesn't cover it?
No, it doesn't cover it. So it covers interworking between an EVPN domain and MVPN or PIM, but not from EVPN to EVPN, two different EVPN domains. That is the part that is missing.
Okay, all right.
Okay.
Okay, thanks.
All right, thank you.
Okay, so next is Jeffrey.
Okay, I have two presentations. I'll try to cut off 5 to 10 minutes of this. First one is about small enhancement to the BGP MVPN. And next slide, please. So with BGP MVPN, there are two routes. We call it C-multicast route, type 6 or type 7, corresponding to PIM, STAR-G, or SG joins, respectively. To support the PIM ASM mode, we can either send the STAR-G join across the provider network or just stop it at the egress P and then sending the SG joins instead. So in the later case, we call it SP-only mode, in short. The way it works is that if you look at the lower right corner, the CE3 has a receiver. It sends a STAR-G PIM join towards PE3. Now, PE3 will hold it, will not do anything when you receive the STAR-G join. But then when the source starts sending, and the CE1 router will send SG PIM register message to the customer RP that is on PE2. When PE2 receives that, it will send the source active routes at step 3. And then that source active route is received by every PE, including PE3, who will send the semantics route for the CSCG join towards PE1, which is the ingress router for this source. That's at the step 5 or step 4. Then PE1 will send the SG PIM join towards CE1, and then the traffic will start flowing. So this is how we achieve this ASM anycast source, multicast source mode without sending the STAR-G join across the core. This is called SPD only mode. Let's just break background on this. Next slide, please. So there is one deficiency in this solution. Let's say that PE2, the session goes down, or for whatever reason, PE3 invalidates that source active routes from PE2 for whatever reason. Then PE3 will withdraw its CSCG C-multicast routes. Then PE1 will stop sending traffic. This is not desired because the failure related to PE2 should not affect this flow at all. It's not even in the path. Next slide, please. There is a solution to this, and in fact, it makes sense, and it's actually goes with the design principle in this BGP MVPN. Basically, in this case, PE1 can also advertise the source active routes in this case. In that case, when that is done, PE3 has two source active routes for the same flow, both from PE1 and PE2. And as long as there's at least one left, PE3 will not withdraw the CSCG C-multicast route, so traffic flow will not be disturbed. This is actually aligned with the design of the source active routes The purpose is that the social active route is the purpose is to announce sources. In the RFC 6514, it talks about that a PE learning the sources will advertise their routes. It listed two ways. One is that a PE is a customer RP rendezvous point, or the PE has a MSDP session to learn the sources. But it does not mention other ways of discovering source, but there could be many ways to discover the source. Next slide, please. So the proposal here is that a PE, as long as it's learning the sources, via any methods, it can advertise source active routes. The RFC 6514 already listed two, which is in the first subbullet. And then in this draft, we are saying that any way of learning the active source could advertise as source active routes, and including the provisioning or pin flooding and that used for source discovery. And the last one is suggested by Mankamana. Going with that, a PE must withdraw its source active routes if the source is no longer active. Next slide, please. It's a very simple enhancement. We believe it makes sense. We appreciate comments here. And if this makes sense, we could either progress this draft separately or fold that into a possible RFC 6514 BESS drafts, which I will talk about in the next presentation.
Thanks, Jeffrey. Any comments? Okay, Himanshu. You're in. Himanshu, you're not in the queue. Can you use the Himanshu? Can you use the tool, please, to get in the queue, because we have others in the queue as well.
Next time. So, what did I understand correct? What is the? How is this related to EVPN? This was all about MVPN, right?
This is for MVPN.
Yeah. So that's why I'm asking, how is this related to EVPN?
Did I see EVPN? If I said
no, you didn't say it, but this is being discussed in the EVPN.
This is BESS.
Oh, this is BESS.
Not EVPN.
Oh, okay, okay.
It may seem like the EVPN working group, but actually it's BESS.
I'm treating BESS as EVPN. Sorry.
Sandy Zhang ZT, let's go to page 2 or 3, please. Oh, yes. Let me see this figure. I think that if I understand right, the proposal of this draft is to said we let the multi-homing PE, both of the TE send the SG join message, right? Not a SG join, as a SG advertisement.
The SG join is only sent by PE3, but the PE3 needs to wait for the SG source active route from someone. If you strictly follow the existing RFC, in this case, only PE2 will send that source active route.
Yeah.
And that has a problem if the PE2 goes down or whatever, if that route is invalidated. So if PE1 also send the SG source active route, then we solve that problem. So a generous proposal here is that any PE, if it learns the sources on its side, it can advertise their source active routes.
Yeah, that answers my question. Yes, I think that is useful in many deployment scenarios. So I think it's useful, and but I don't think that can be discussed, because if we want to do something to update RFC 6514, there may be some large modifications should be done, I think. So I think it's an opportunity to review all the contents in RFC 6514. Yeah, so we can do some revisement for that FC. Yeah.
Right. That's why we're talking about having the next presentation.
Thanks.
So a possible RFC 6514 BIS drafts came out of a chair's discussion when we were looking at adoption requests for two drafts that I mentioned earlier during the working group status updates. So this reflects some thoughts that we chairs have. We just want to share them here and then see how the working group feel about it. Next slide, please. So RFC 6514 is an enormous specification itself for BGP and VPN, and also has a lot of follow-up specifications. In particular, the first RFC after that, 6515, is a clarification. It just explains how we can know whether some addresses in the routes are IPv4 or IPv6. And then there are some simple feature extensions and large feature extensions there. I'm not going through those. I'll just skip to the next slide, please. We do notice that there are two protocol issues in the base spec. The first one is in the inter-AS case, if you're doing upstream PE selection based on the unicast routes, you may get into traffic black holes if you're using selective tunnel, or you can get duplications if you are using inclusive tunnel. In that draft Zhang BESS, MAP, EVP, and C-multicast enhancements draft, section 1.4 talk about those issues, and it also talks about solutions to that issues. The next one is if you're using non-segmented inter-AS using IPv6 infrastructure, it just does not work because we need to use the source AS field in the C-multicast routes, which corresponds to the PIM joins. In the IPv4 case, we use the source AS field to encode upstream PE's address. That does not work for IPv6. I'm going to skip the protocol details here, but there are two solutions proposed in that same draft, C-multicast enhancement draft, and in another draft, MVP and IPv6 infrastructure drafts. We have had a lot of discussions on the mailing list between the authors of these two drafts. We have not reached a conclusion. Just I think on Monday, I sent out another email to revive that discussion. At least my personal opinion at this time is that we have a simple solution in the latest version of the C-multicast enhancement drafts. That's just my personal opinion. We need to discuss it further on the mailing list. Next slide, please. So there are also some desired enhancements. The very first one is what I just presented, a very simple enhancements. And there are some other enhancements that's including the drafts and listed here and other enhancements. And those enhancements, probably it can still be tracked progress separately. Next slide, please. So if I mentioned earlier that this BIS draft was brought up when we were considering the adoption request for those two drafts that have separate solutions for the same problem. So the BIS draft could try to address the problem, but or that the problem could be progressed separately as well. But either way, we first need to decide how we're going to solve that problem. Next slide, please. So let's just say if we decide to go with a separate BIS draft, go with the BIS draft, then we would add solutions for those two protocol issues I mentioned earlier. We could also fold that source active route enhancement that I just talked about into this. And we can also fold some of the existing RFC content into this BIS draft. For example, 6515, the infrastructure address issue, that clarification. And the wildcards and the MLDP FAQ encoding, those are the basic, actually they are basic features of the BGP MAPN. And also RFC 9081, the source active routes interaction, they could also be folded into this, but there are a lot of other RFCs content, they should be tracked separately. Next slide, please. So working group discussions, especially on those two outstanding protocol issues and their proposed solutions. We need to discuss them, decide what to do with those, and then decide whether we want to have a BIS draft or not. So that's basically the presentation.
Okay, I think we have a couple of minutes for any comments or questions.
So quick question, Jeff. First,
This is
I
Ali.
think
Ali, can you just state your name first, please?
Sure, Ali Sajasi. So Jeff, first, I think it's a great idea if we can consolidate a bunch of these drafts into the BIS, makes it much easier for someone to reference and also avoids duplication a lot. The question I have is on page 2, I guess, the list was much longer than page 6. So is page 6 list is a subset of page 2? Or was it 2? Or yeah, this is page 6. And then if you go to page 2.
Right. So there are a lot of feature extensions. I don't think there are, some of them should be folded into it. For example, the global table multicast, and actually that could be discussed, but then there is a virtual hub and spoke support, inter-area segmentation, and upstream redundancy. I think those those features could be better tracked separately, and instead of being folded in the single one. Yeah.
Okay. Thanks.
Okay.
Jorge Rabadan. Yeah. First of all, I think it's a good idea to have a BIS version. A question for you, Jeffrey, is it the goal of the BIS version to have just the 6514 text with references to the new RFCs, or to actually add the text on top of it? Because otherwise you end up with a huge spec, right? And maybe it defeats the purpose. So I don't know what your thoughts are.
Have not thought about the reference aspects. We have some protocol issues to address. We also have some existing RFC that adds clarification or some simple enhancements to it, and those would be nice to be in the same RFC. That's how we started this. And as far as reference purposes, we have not thought about that.
All right. And the other thing is there are a couple of them that are relevant not only for MVPN, but also EVPN. If you fold them into the BIS document, then you still need to address EVPN somewhere.
Right. So yeah, the C multicast, MAPN, EVPN C multicast drafts, that one covers quite a few issues, including the solution for the MAPN protocol. If we were going to do a BIS drafts, I would think that only the MAPN related smaller issues or fixes will be added to the BIS drafts. The EVP related or larger changes is still better to track them separately.
Different document. Okay, cool. Thanks.
It's on the right sides, is it? Which one is it? I'm looking at the agenda. The slides are on the wrong one.
let me try to.
You try and do it.
Yeah, I'll try to do it. I don't see it.
The first top security ones, but not the.
Yeah, let's do this one first.
I'm getting feedback from yeah, you can use that. Yeah.
Hello, everyone. I'm Krishna Swami. I will be presenting on behalf of my co-authors. I would like to, welcome both Ore and Van to join this draft. Okay. So this, the EVP and the first off security draft was presented in IETF 116 and the revision in 117. So just a quick recap, right? The first off security features like ARP, dynamic ARP inspection, ND inspection, IPv4 and IPv6 source group. So those today, when we enable it on EVPN in the EVPN deployment, so there are some limitations with respect to multi-homing and mobility. So a new EVPN route has been introduced, the DHCP sync route, to synchronize the DHCP binding between the ESI peer, multi-home peers, and also to remote peers. Okay, so the changes in the layer in this particular version, there were a few comments from Ore that we have addressed and also made some editorial changes. So, we request the members to provide any comments or suggestions, and also we feel that this is ready for a working group adoption. We have an implementation also on Cisco Nexus devices.
Ali, you're in the queue.
Just want to add that acknowledge Jorge's contribution. He had some very good questions, and as a result, it helped the revision of this draft that we did a lot of clarification. I mean, if you do a diff between this rev and a previous rev, you will see the amount of the clarification that we've made to this draft. And as a result, the draft is in a pretty good shape, especially for the working group adoption. So just wanted to mention that.
Thank you, Ali.
Sure.
David Lampunter, are you planning to support snooping DHCP-v6 prefix delegation, which would need to install prefix routes rather than host routes?
No, we haven't looked into that.
Okay, that might be worth spending some cycles on.
Okay, thanks.
Eric Klein, is this this is more than just DHCP though, right? This is all sort of savvy bindings actually, right?
No,
everything that could be a binding anchor for savvy?
No, not for the savvy.
But it's essentially all the same information, is it not?
Okay, so maybe I will answer this question on the mailing list.
Sure, thank you.
Okay, thanks. I'll move it. I think we found the slides for the next one.
Okay. Yeah.
No, it's because I'm sharing it. Just say next slide. I'm not putting it up. Just tell me when you want the next slide.
Okay. Yeah, next slide. So thank you, Jorge, for joining this draft and also providing all the relevant inputs. Next slide, please. Okay. So the Rev 0 was presented at IETF 118, and in this revision, we have done some editorial changes, and also we have removed section 5.1, the gateway MAC mobility procedures. So we are now referring to RFC 7432 base because that already provides the details. Yeah, next slide. So in the last IETF, we were not able to go through the entire presentation due to the shortage of time. So we thought, we will go over it again for the benefit of members. Next slide. Right. So this particular draft provides architecture and operations for EVP and centralized gateway for first stop routing for overlay subnets, on a centralized IRB. But there are no changes with respect to the bridge traffic, which is still located on the layer 2 PEs. So this architecture makes use of asymmetric IRB defined in RFC 9135. Next slide, please. Yeah, let's look at the control plane operation, right? As in this diagram, the hosts are connected to the layer 2 piece, and we have a set of redundant centralized gateways. So the first operation on the centralized gateway PE is to advertise the default MAC route, right? So now, and also the MAC IP routes received from the L2 only PEs will be imported into the MAC verf for the bridging, and it will make use of the asymmetric IRB procedures for IP to MAC MAC binding. Okay, and yeah, next slide, please. Right. So on the layer 2 gateway PEs, right, we define ARP and ND snooping is a must because this is going to simplify the architecture in a way that the CAG PEs they don't need to do any data plane learning and no need to synchronize the ARP and ND table between the redundant CAGs. Also, the L2PEs can also enable this the snooping, right, where they could store this gateway MAC in the ARP and ND cache, such that locally they could respond to ARP and for the neighbor solicitation request. Okay. Yeah. Go to the next slide. Yeah. So now just look at the data plane operations. As you see on the right-hand side, the L2P is if it is a bridge traffic, so there are no new changes, right? Now, the VLAN, if for the IP traffic between the VLAN 10 and the VLAN 20, right? So the L2PE is going to do a bridging for the traffic because it receives with a CAG, the gateway MAC IP from the CAG PE. So on the centralized gateway PE, we we do an IP lookup, and that will, if the subnet is locally attached or it is part of the L2 fabric, then the lookup is going to lead to an L2 the MAC adjacency where it it follows the asymmetric IRB procedures and rewrites the MAC and forwards it to the L2 PE. If it is an L3, if the subnet is not attached to the locally or to the L2 fabric, then the lookup is going to derive an L3 VPN tunnel and will be forwarded to the L3 PE. Yeah. Next slide, please. Okay. So as I mentioned earlier, right, so we will be referring to the procedures on 7432 BIS. Yeah, next slide. Yeah, so there are two deployment models now we have listed in the draft. The one is an interconnect. So basically, segregating the layer 2 only domains with layer 2 and layer 3 domains. In this example, it will be the domain 1 will be the layer 2 only fabric, and tunnel 2, the domain 2 will be the layer 2 and the layer 3. So the CAC PEs will be stitching between the both the domains. So this model is is quite scalable because we are segregating the domains. And yeah, the CAC PEs have to do the necessary whenever they are advertising the routing the MAC IP routes from one domain to other domain, change the next step to the CAC PE and also update the labels. Next slide, please. Yeah. So in this model, right, the CAC PEs are also providing distributed anycast gateway services for the hosts which are directly attached, and providing centralized gateway services to the layer 2 fabric, the host behind the L2 L2Ps. So this model simplifies the operation where there are no separate domains here. So, but most of the other procedures, what is going to be the same with respect to the control plane operations and data plane operations. Yeah, next slide, please. Okay. Yeah, we request more feedback and comments from the working group members, and also we feel that this draft is ready and good for a working group adoption.
Himanshu.
Himanshu from Siena. So while I read this, I didn't see anything different than what is already specified for asymmetric IRB. Is this just a documentation of various network topologies and how and where asymmetric IRB is useful and all that stuff? There's nothing protocol related changes or nothing.
That is true. We are not providing any protocol related changes. Yes. So this is like, we are providing how this could be deployed. Yeah.
Yeah. Okay. So this is informational RFC type of progress.
I think we could make it informational, but maybe, yeah, we can discuss on the list.
Okay.
Sure.
So can I just get maybe a sort of sense of the room about who's read this draft? I'll do a quick. Better give it time. Start a quick show of hands poll as well on Meet Echo. For those who are just entering the queue, actually you can use the poll. So sorry, can you raise your hands again in the room if you've read it? Okay, we've got about the same number virtually. Okay, thank you.
So Neeraj?
Yeah, I just wanted to comment on the, whether it should be informational or stands. I mean, we can certainly discuss on the queue a bit more. There are, even though there are no new, on the wire protocol or routes that, protocol aspects that are defined, there are certain, there are certain must-haves that are defined with respect to doing ARP-ND snooping in order to avoid, in order to avoid ARP syncs and data plane-based ARP learning on the CAC PEs and so forth, right? And so yeah, certainly open to suggestions, but that's the reason why it was, originally put on standards track.
Okay, any other? Okay, that's good. Thank you.
Okay, thanks.
Sorry about the feedback from the mic at the front here.
Okay, so this is second time I think presenting here. This is for the BGP enabled service for SRv6, and those are the. Let me go through. Does it work?
Just tell me, Linda, because that's not plugged into it. So.
Next. Okay, so here's a scenario. Okay, so in the SRv6 domain, most of traffic goes through SRv6. Those are perceived as secure because it's provider managed network. But there are some special flow or services like financial service or high sensitive services require encryption. So this is for this scenario. This is very similar to secure EVPN. The secure EVPN encrypt all the client traffic over EVPN, but this is only select a few, maybe one or two flows, encrypt them and place them onto the SRv6. Next page. So here's the desired data plane. The encryption is for the payload, and SRv6 SRH header has to be outside encryption so that SRv6 network, all the PEs can place this traffic following the particular policy through the SRv6. So that's the desired data plane. Let's look at the control plane. So the control plane is very similar to SRv6. You may have the preset BGP prefix set. Those has to be there. The only one thing need to be added is very similar to secure EVPN is adding the encapsulation tunnel encapsulation attribute. With the tunnel encapsulation attribute, it can specify which IPsec SA this particular flow need to be placed into. So the node can inform other peers of the desired IPsec properties. And we need a new tunnel type. We call it ESP payload. It's basically ESP encrypted payload for those kind of flow. And more importantly, the set has to be outside. Okay. So here just the summary of what we need. We need a new tunnel type called ESP payload. I think in secure EVPN they have transport or UTP transport, but this one doesn't need that. Just need a new type. And all the other sub-TLVs to describe the IPsec is already described in the IDR draft called SD1 Discovery. They have defined all the sub-TLVs, define either sending the exact information about the IPsec or pre-established IPsec may include the IPsec ID sublist. So that's it. Next slide, please. So the next step. So this is very similar to EVPN, a secure EVPN. So option one is to adding a new type into secure EVPN. However, the secure EVPN draft has been stalled. It's been expired. So I'm not sure if the authors want to pursue that. If they don't, then this has to be followed independent separately. Okay, I see Ali is there, so I need his feedback on if he is going to move forward with the secure EVPN.
Go ahead, Ali.
Okay. Yes, I mean definitely we want to move forward. It just the queue for the, as you know, the queue is so so long that our existing draft is not moving forward, let alone the new draft. So, however, I will resurrect it and I will ask for a working group last call. But as you saw, the working group last call queue, it is pretty long. First. Second comment that I have is in section 9. So when you're asking about merging with EVPN draft, are you asking to add this new encapsulation as one of the encapsulation we have in section 9?
Yes, we are asking to add a new tunnel type. You define the 2 tunnel types in your
Right.
secure VPN, right? So we would like to add a new tunnel type to indicate this particular flow need to be carried by HRV6 and then give the sub-TLVs, which is similar to what you have described in secure EVPN.
Sounds good. I mean, we can discuss it offline. There are, so this is very similar with VXLAN. Instead of the inner header, the encapsulated or encrypted, I should say, encrypted packet to be VXLAN packet, the encrypted packet in here is, what was it? Let me see the format that, I'm sorry, the format that you have in here. I missed, okay. I missed the,
Forward, backward.
hold on a sec. Yeah, I mean, if you go back to the encapsulation.
Yeah, this one. This is the desired data plane. So only difference from your VXLAN is your VXLAN header is inside encryption, inside ESP tunnel. And here our V6 header, SRv6, SRH has to be outside. So that's the difference.
Right. So so the inner packet is good old IP, and the outer is IP for SRv6.
Yes, yes. So it would be great if we can add a new tunnel type into your secure EVPN, make it just simple, just another
So let's
additional.
sure, let's discuss it. Then one other question is with respect to the NAT traversal. Have you considered how these SRv6 does it need to go through the NAT traversal? And if so,
No, because it's a V6, so it doesn't need NAT.
For the even though for the prefixes on the prefix part? In other
No.
words, from the okay, so let's have a quick offline chat, and I think talk about the whether we only need this NCAP to be part of the section 9 or we need something additional.
Okay, thank you.
Sure.
Yeah, Linda, this is Darren Dukes. Just a note on the desired data plane encapsulation. This is essentially what already exists for ESP over IPv6, right? There's nothing new here.
No, there's
Okay.
nothing new on the
Thank
data
you.
plane side. Yeah, thank you.
Okay, we'll move on. Thanks.
Thank you.
Linda. Okay. Ali.
Can we do the other one first?
Trying
the
to find the other
policy. Yeah.
Yeah, the view I'm getting on data tracker here isn't the same as the view that there seems to be it seems to be out of sync with what we thought we had uploaded.
The LRS BESS EVPN group policy, you don't have that?
Yeah, I found it. There you go.
Okay, very good. Awesome. Okay. I am presenting, this is a list of the authors, and I'm presenting on their behalf. Next slide, please. So a little bit about the history of this draft. It is a merge of the two drafts that have been around for quite a while. One draft Smith VXLAN group policy, and the other one WLIN BESS group policy ID extended community. So one is on the first one is on the data plane, how to incorporate group policy ID in a VXLAN header. And the second draft is how to extend EVPN and pass this group policy ID. And it uses extended community as the name implies. So the two drafts, the reason for the merge is there's a lot of synergy between the two drafts. The two drafts are pretty short draft, and they are complementary to each other. One talks about the data plane, and the other one the control plane, and it is both, the two are both sides of the same coin. So that's why the decision to do the merge. Next slide, please. So the data plane draft has been around for over 10 years. I mean, it first got published 2014, and it has been implemented by multiple vendors. And the control plane draft has been around for almost 2 years, and it also has been implemented by multiple vendors. So although the revision is Rev 0 individual, but it is misleading, the revision, because it is a merge of two drafts which has that have been around for a long time and been implemented already by multiple vendors. Next slide, please. So the whole thing is very simple and straightforward. We are adding in the VXLAN header, we are incorporating the group policy ID in the reserve field. And also we are adding a couple of flags in the reserve field. And you can see the group policy ID on the upper right portion of the that used to be a reserve field. And the two flags on is one G bit, the first bit, and then the other one is A bit, which is in the next slide, and we're going to get to it. So the whole idea of this, I think, the idea of this group policy ID is very well understood, that you associate a group policy ID for a number of users or a number of applications, and based on this group policy, you decide, based on this group policy ID, you decide which users to have access to what applications and who to talk to who at the policy ID level. So next slide, please. Oh, before going to the next slide, the GBit, again, pretty straightforward. If you have the GBit set, that means the policy ID is present and as defined in this draft. And if the GBit is not set, then you treat it just as the reserve bit, which is 0, and based on the RFC 7348. Next slide, please. A-bit. So A-bit says that whether the policy being applied or not. So if the A-bit is set, means the policy has been applied and doesn't need to be applied yet again. But if it is not set, then that means the receiver should apply the policy. Next slide, please. So on the control plane, again, on the data plane, we have the policy ID. On the control plane, we define a new extended community to pass this policy ID. And along with it, we define a policy ID scope to help for the interdomain when when different policy IDs for different domains are basically they are defined in the context of that policy ID scope. So different policy ID scope will have different 16-bit space. And that comes in handy when you go from domain to domain and you need policy ID translation. Next slide, please. The draft talks about 3 cases of backward compatibility that needs to be considered. One is when the NVEs don't support this group policy in either data plane or control plane. Second, NVEs that support group-based policy in the data plane but not control plane, and NVEs that support group policy in both control plane and data plane. And a network can consist of all 3 of them. And the question is to ensure a network that has a mix of these, they're compatible and it can work. So the draft talks about these 3 cases. Next slide, please. So interconnecting multiple EVPN VXLAN domains, the draft covers that and says that the domains can have different group policy ID assignment. And thus, when we go from one domain to another, the policy ID needs to be translated or change. And a scope ID basically facilitates such translation because it identifies what domain it belongs to. So it's used for that purpose. Next slide, please. So given that, these 2 drafts have been around for a while, and if you look at the draft, I mean, we are not introducing any new thing in here. It is really the merge of the 2 drafts for purpose of the simplification of going through this process and making sure that when the reader reads the data plane part, also reads the control plane in one place. So they've been around for quite a while. It's been implemented by multiple vendors, and based on all these, the authors would like to ask for a working group adoption call. Even though it is Rev 0, it is truly not Rev 0. I mean, you can think of it, we are asking for working group adoption of 2 existing drafts,
Thanks, Ali. I'm just going to put 2 hats on at once here. This is BESS chair and NVO3 chair. Typically aspects of VXLAN data plane have been done in NVO3. And there is also, in addition to that, I think we can typically do extensions to VXLAN, but actually any changes to the VXLAN header are not really owned by the IETF per se. There was the actual RFC for VXLAN was done through the independent stream. So I think we need to look very carefully on where that part of this work sits. There's probably a reason why, in a way, why Draftsmith hasn't been published. It kind of needs a home. So Jeff, I see you kind of nodding as well. If you want to say anything from a sort of routing working group perspective.
I didn't put myself to the queue. So I agree with Matt completely. Data plane extensions should be done in NVO3 probably, if anything. And the GBP draft has never been adopted and actually considered as a hack on top of VXLAN. So even so draft does exist and it's useful, and there's variety of implementation, mentioned all vendors. I mean, IETF process, it didn't come to consensus about the draft, right? So we are de facto standardizing the implementation, not the other way around. So I understand why you are merging it. It simplifies a lot, but there's work in NVO and there's existing draft in BESS, so the W lens draft. So do we really need this draft to merge stuff that doesn't really belong in BESS? I'm not sure. It's up to chairs, obviously.
So let me respond. Okay, good points being raised by both of you. And if you look at it, there basically we've had precedents where we needed to modify the data plane, and we've captured it in the draft, and we present, we covered it in the BESS. And this one is I don't know, to me is pretty like a simple and a straightforward. We had like in NVO3, we had multiple camps, one on the Geneve, one on the VXLAN, and one on the NVGRE. But within the VXLAN, it was a single camp. And are you saying that within the VXLAN camp, there is there are some concern with respect to this encapsulation?
I'm not aware of any concerns regarding VXLAN, but just a little bit of history on the standardization of VXLAN. We were not able to take VXLAN forward as a standards track RFC in NVO3 because basically it was brought in by various vendors that wanted to retain some control over it. So it went through the independent stream. So
Okay.
So I don't know what the status is of making standards track extensions to that.
No, so that's actually a very good point. So we can change that to informative. I mean, from a standardization.
Yeah. Well, let's kind of take this offline and have a discussion with our AD and between the authors and us and the AD over where this part of the work sits.
Sounds good.
So just quickly, Hoke, I think you're.
Yeah, Jorge Rabadan. Irrespective of where this is done, I think it's, we want or not, VXLAN is all over the place, and this is a good solution for VXLAN. So that was one comment. Ali, I had a couple of questions about the document itself. So in one section, you say that the extended community, you can advertise it with an ID per EVA route when the group policy ID is associated to the attachment circuit. Is that even without multi-homing, or you meant with multi-homing?
That's both, with or without multi-homing. Because if it is on a just AC basis, then I see where you're going with that, because the ESI of a single homing is 0. Okay.
Yeah.
So that presents a bit of challenge. So sounds good. Let's take it offline on that one. Okay. Maybe it is going to be just limited to the multi-homing.
All right. Yeah, and the other one is there's a section about eVPN to IP VPN interworking. I understand the control plane aspect and the propagation of the extended community, but what about the data plane? Because obviously in the eVPN side of things, you have VXLAN, but on IP VPN you don't. So that section, I guess, is only valid for the ingress enforcement, but not the egress enforcement. Is that correct?
Between the VX for the VXLAN can be used for also in case of the IRB, right? The VXLAN encapsulation can be used for the L3 routed. We are using the MAC address of the gateway as the inner MAC.
Sure, but I'm talking about a specific section on IP.
On the just for L3 VPN.
Yeah,
so
yeah.
that for that one, I think I agree with you that if it is just if it is just L3 VPN, I think it might be unidirectional enforcement. Is Ven on the call?
Yeah, I can take that question.
Go
Ven,
ahead.
did you?
Yeah, can you unmute me? I can take that question.
We can hear you. Just go ahead and
go ahead.
then we need to move on very quickly because we're nearly out of time.
Yeah, Jorge, you brought a good question. The reason this is put it in there, we haven't put the whole content on that because there still need protocol work. Because when we go over from the boundary from VXLAN to MPLS, VXLAN is okay. You can put the group-based policy in there. When it comes to MPLS, it does not. But we are actually it's not spelled out in the draft, but whether to translate to a special label or basically different MPLS label mechanism, we're still evaluating. That's why we need that to go across the MPLS network, but it's not spelled out in the draft yet.
Okay.
So basically work in progress.
Gotcha.
Yeah.
All right. Thank you.
Okay, last comment from Aijun, and then we have to close.
Yeah, Aijun from Thailand. I want to know what's the driving force to reactivate the draft. And as you explained, the draft had existed about 10 years. So is there any other new use case to reactivate? And the reason that I ask this question is, you know, we have proposed some other use cases, but the similar control plane and forwarding plane extensions. So I think if there is no other new use case for these two draft, we want to merge the two proper together because our solution is similar.
So I don't know what your solution is, so I cannot comment with respect to merging further. But if it is on the, I mean, this is very straightforward, very simple, and is being in deployment for quite a while. So if you want to discuss with respect to your proposal and what you're talking about, we can consider it. If it is mergeable or not, that is fine. We can discuss that.
Yeah, the current two proper is the use case is different, but the solution is very similar. So
I mean, is it the VXLAN base?
Yeah, we also do the VXLAN extension and also the control plane extension. But we use different control plane extension mechanism.
Yeah. Can we move on? Actually, I think we need to sort of take the discussion to this because I just want to give Ali like 5 minutes because we are technically out of time.
Yeah, we'll take the discussion list. Okay.
Thanks.
So I'm gonna skip my E3 draft for the sake of the other draft, and let me give you a few minutes to the last to the optimized IRB, and frankly, that is so maybe a few minutes should be sufficient. We are almost out of time, and that is not fair for the next presenter
We are
So,
out of time. We are out of time. I'll give this. So this, you're saying you're going to do this one?
yes.
Yeah.
Can you just keep it very short though, and then we
Okay,
have to close.
François, go ahead, please.
Yes, sure. Thanks, Ali. So yeah, I'm presenting the L3 optimized IRB, and we are welcoming Jorge to be a new co-author. And in the Rev 0 actually has been presented in the IETF 118 and covered overall solution. And in the Rev today we're going to cover Rev 01, 02. So basically we're providing a new option, option B we called, and also propose the IRB flag. And in Rev 2, we add some COVID, the caveats and also the MAC-only MAC-IP route handling. And also we expand the coverage to the IPv6 and the message as well, handling as well. Next slide. Yeah, this is the because of a time constraint, maybe quickly go through this one. This is the Rev 0 we covered, why we need this L3 optimized IRB. And fundamentally, the idea is to make the intra subnet bridging as to be routed as well, so that from the PE side, the PE only need to maintain the local connected IP host MAC. In the traditional bridging, all the PEs has to install all the remote host MAC. And with the L3 optimized IRB, the PE only need to install the local connected IP host. So that's the greatly improve the scale. And in the Rev 0, we covered the option A, which is the unconditional ARP response, and also covered the interop as well. So next slide. In the Rev 01, we added a new option, which is the optimization on top of the unconditional ARP response. So in this case, when the L3 optimized IRB will only respond to ARP request if a host is known. In the previous one, even the host is unknown, it's gonna respond and attract traffic and cause the first data packet loss potentially. And if this in the option B, if the target host is unknown, the P will not respond the ARP request immediately. Instead, it's going to re-originate the ARP request to discover the host across the fabric. Next slide. And once the host is learned, for example, in this case, host 2 respond, and the host 2 is learned and advertised via the EVPN RT2 MAC-IP route. And then after that, all the subsequent ARP will be respond with the correct host 2's MAC, so that it becomes known on the P1, and then the data traffic will keep flowing from the on. Next slides. And the advantage of the option B is it solves the first data packet loss issue, which might be critical for some application like TCP or some application which is very sensitive to the packet loss. And also, it will not create the unnecessary ARP cache if the target host is unknown, because option A is going to unconditionally respond, and in the option B, it will not respond if the target host is unknown. And from the interop point of view, choosing option A and option B is a local matter, so it will not create any interop issues. Essentially, the target host actually is discovered by the ARP request, either being originated or by re-originated. So option B is the recommended approach. Next slide. In the Rev 1, we also propose the L3 optimized IRB flag to be the bit 16 of the existing EVPN ARP and the extended community defined by the IFC 9047. Next slide. And in the Rev 2, we added some new caveats on top of the existing one, like TTL specified in Rev 0. We added 2 more, like the IPv4 ACD is not supported, and the NUD is not supported from IPv6 point of view, because fundamentally, if we allow those packets to go through, it could pollute the CE's MAC table. And actually from L3 optimizer RP point of view, they are not needed. Next slide. And in Rev2, we add the, because from EVP point of view, EVP allows advertising the MAC only and MAC IP route. So for L3 IRB, usually we just use the MAC IP route. So we add a statement saying PE should not advertise MAC only route, and PE must advertise the MAC IP route with the L3 optimizer IRB flag. But if a PE choose to advertise both MAC only and a MAC IP, then both should carry the same flag, so that on the receiving side, the MAC will not be installed in the data plane as defined by the Rev 0. Next slide. In the Rev 2, we expanded the message handling to the IPv6 ND as well. So the procedure is pretty much the same. And I'm not going to cover all the details, but overall, the behavior are same as ARP message with some IPv6 specifics. Next slide. So yeah, we are solicited for more input on the mail list, and also we are asking for our group call. Thank you.
Okay. Thank you. So I think that brings us to the end of the session, but can I just ask people to review this draft and send any comments to the list. And with that, I think we're more than out of time. Thank you very much, and see you in Vancouver. Can you hear that? I can hear there's a very high pitched piece of feedback coming through from somewhere. Yeah. Is it? Can you hear that? The feedback. Did you hear the feedback? Can you hear that?
I didn't hear any feedback.
There must be a standing wave in the room. Can you hear that?
Yeah. No.
Yeah.
Yeah.
No, it's very high pitched. It's like 15K or something, isn't it? It's like really up. Yeah. Yeah.
I cannot hear anything.
Yeah. It's very high pitched.
Yeah. Where should I put the notes?
You just email them to us and Simona. You did them on just on the separate app, right? You didn't do them online, right?
Yeah.
Yeah. That's great. Thanks very much for your help.
No, I'll clean it and send it to you. Okay.
So on that the Excel stuff, I agree with you.